Pe, baba, leta. Aki we ni chiki. We ni chiki, sijui tabia umetoa wapi. Hebu mnyang'anye hiyo raba. Mm.
Hi guys, Assalamu alaikum. Good evening, Mr. Greg.
Hello, hello, Hassan.
Hello, Mr. Greg. From some days you are not joining the class. Any specific reason?
Yeah, it collided with some of the work meetings that I've been having.
Okay,
Yes.
okay. That's
Yeah, yeah.
that is a big issue for the job order persons.
Yes. So, but
I
otherwise, I'm
see.
following slowly by slowly. Yeah.
Yes, that is like the big issue for the job order persons.
Yeah.
Yes. Um, Me too. Whole day I'm just joining the meetings and meetings. Because we are working. we are working with the Chinese companies, and Chinese, oh my God, they only need the meetings to meetings. They all day they play the with the meetings.
Yeah, I know, I know.
Whole day. Today I have just three to three to four meetings per day.
Ah, that's a lot.
Oh no, some from the for the client side, some for the internal meetings, and the oh whole day just play with the meetings, meetings and meetings.
Yeah, yeah.
Yes. Okay. Okay. Kindly see the recordings, and if you have any query, you can raise concern in the group.
Okay, okay. Thank you.
Okay. Okay. So, Mr. Kazi, any issue? Are you satisfied?
Sir, as I said the last time, I am not the electrical engineering background from civil engineering background, so there is some terms which is out of my knowledge actually.
Sorry, I
And
don't get your.
for instance, like yes, I'm working in this field for a long time. Actually, I'm working as a structural engineer in this field,
Okay. Okay.
and
Okay. That's great. That's great.
but
Uh,
electrical side is not my part of the job. But as I started my own company, that's why I'm studying here.
okay,
And
Mr. Kazi, I think it is just you need some basic information regarding the electrical. You no need to like in the full detail. Just you know the basic things like the electrical things when you will go with the main clients discussions. Maybe you have the some technical person with you from the electrical side, but if you need some discussion with the client, then you have to know about the main electrical things.
yes, 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 yes. Actually, I have actually my partner is an electrical engineer, and I told
Okay,
him
that's
that
great.
he is doing MSc in Dhaka University in this field, and
Okay,
I am doing this course according to his suggestion because
okay, okay,
mainly the clients is I maintain the clients. That's why I
okay,
need to meet with them and need to convince them regarding the issue. And this field is too much new in our country. That's
okay,
why
okay,
people are not that much known about this.
okay. If you need any help from my side, uh, like a discussion with the client and other things, uh, I can provide you the without cost. If you need any help to satisfy the client, you can refer to me. I will satisfy the things, but I need just basic information from your side. I will communicate with on the behalf of you. No issue. If you need any help in the future regarding if any client is too much like technical points, so you can refer to me as an help, as a friend, as a teacher student. So I can like provide you the uh, support in that issue.
Thank you, sir. That is a
Uh,
great honor.
like, no issue, no issue. Thank you very much. So another point, basically, uh, regarding in the previous batch when you talked to me regarding this course, and I have the plan to quit this sessions, but you said me that I need this trainings and other things. Then I start the this third batch. And also, Mr. Greg has paid the payments before the start of the date, which I have committed the 15th December. And due to some health issues and other things, I have the plan to cancel the this batch. But I have already received the Mr. Greg payments. and my faith and other things will not allow me to do that, to quit at that time. So that is why I just start the session late, but I have started that session because in that field I have some repo, and I don't want to like go uh, in the dark, that some people will know me and they will follow me, and I will just lie to them and go spread the false information with everything. So that is why from now on, maybe I just quitting these sessions, because due to the time management and other things, because at that time our company has like four projects in, like in the parallel working. We are working as a detail engineering on one is like 600 megawatt, one is like 80 megawatt, the other one is 200 megawatt, and the third one, fourth one is 30 megawatts. So that is why our team is too much busy on that projects, and maybe I don't uh, uh, have some spare time to do that sessions. That is why I'm just ending that sessions from after this batch, and that is why I have public these lectures on the YouTube channels. And if you are any from your side, any person need that session, uh, because I will provide all of you, which you have provided me the payment. I will provide you the certificate of that on the behalf of my own company. But for the other person which just use that lectures in the free, I will not provide any certificate to them, but they will see on the YouTube channels. To help the peoples, I have just uh, first at the start, it's my decision that I will not public these lectures. But mm, when I uh, think about that, because I am just ending that sessions, and people will need help in that field. That is why I just uh, take that decision. It is very difficult decision for me, but I take that decisions. So your friend which is doing the MSc, you can refer these lectures to them. They can see the lectures, and if they needed any help, they will get from that lectures. So today our lecture is regarding the PVC simulations. Yesterday we have done the simulation report without the 3D shading analysis. So today I have just prepare a one PVC file from the like PV case that I have already used in my client projects. We just preparing that PVC report with with the help of this PV case file, PVC file. Tomorrow our is the last lecture regarding the PVsyst. So tomorrow we will export the one Colorado file from the uh, SketchUp, and then we will import in that PVsyst, and we will do another simulations. So the purpose is to use how we will do the 3D shading analysis, other things. So I'm just need one confirmation from all of you that if we like do the session on the Sunday, because maybe in the next week at the last day, like Friday, I have to travel to my hometown, and maybe our last lecture will skip due to that reason. So I'm just want that we will continue our lectures on the Saturday and Sunday. So one is the last lecture which is remaining from the previous uh, Monday, that is remaining, and one is for the extra for the next week. So we can end up our session at the Thursday, and Friday I will travel to my hometown. without any hesitation and without any issue. Uh, if you have any issue on the Sunday, then you can communicate with me. I will reschedule again on the Saturday. If you don't have any issue, we can continue Saturday, Sunday, the classes. Guys, are you listening to me?
Yes, sir. I have no issue.
Yes.
No, sir, no problem, sir. From Mr. Greg, have you any issue if we do our lecture on the Sunday?
No issue.
Mr. Kazi?
No issue, sir.
Okay, thank you. Okay, thank you. We will continue our lecture by tomorrow and by Sunday. So I'm just sharing my screen and we will prepare a one simulation report today. So here is again that the preliminary phase. So we are doing one PVC simulation on the grid connected systems. But before that, we just prepare a one standalone report, and then we will prepare one grid connected. Because I want that you will know everything which you have to do in your experience. So pumping, I don't have any knowledge about that because in my experience, I don't use that in the pumping PVC simulation report. But for the standalone and for the grid connected, I have used that one and I will teach to all of you. So new project name, we just 14 class uh, practice, sorry, practice standalone. For the location, I just added one location, this one, like I have just one coordinate of that side. Just give me a minute. Uh, just I just this is the for the new side, for the new side. But if you have this already save the location of your site, you can use that one. Click on that. Like we have saved these location in our directory PVsyst. You just click from that one. They will automatically pick that one and you can use that one. Okay. Now here I am just putting the new site locations. So here I have just put the site coordinate and search that one. Like here. Okay, accepted this one. Okay, and then it is go into that one. The monthly file. Import that one, Meteonom files. Import that one. Then we have this again. Yes, Mr. Greg.
Just to ask, when you are importing these weather files, which one is better, or which one gives you a more realistic depiction of of the
Basically,
outcome.
Mr. Mr. Greg, if you have
Yes.
if you- if you have the weather file of the solar GIS file, basically it is the paid one options. In the large scale project, when we are doing the large scale project, client will get the updated data of the near year, because here we are using the meteonome files. Meteonome, basically they are based on the ground based data and satellite based data. So if you have the solar GIS updated TMV file from the client side, or if your company will purchase, that is better. That is because
Okay, okay.
these file is as per your original coordinate, and the data of the weather which is like near years, like previous, like 2024 2025 data. But if you don't have that file, so then you will use meteonome file, meteonome data. Okay.
Okay, okay.
Okay. Okay, then I have just changed that one and select that size, save that one, and okay, I have saved that one. Save the location there, go into the projects. Okay, project settings there, and I have just mentioned the albedo value like 0.2. I have just selected because it is the ground mounted system and urban area. So it is which size I have selected in the Iran. It is around the urban area, so I have selected 0.2 value. But for that one, I have just selected -3 value just as a example. But you have to check that value. I have explained in the yesterday class how if you have that weather file, then you check the lowest temperature from the weather file. But if you don't have that file, you can check from the weather spark data. Okay, then you have to save that one. And I have just variant names like 14 class standalone alone system date 16/01/2025. Okay, then you have to put the orientation, and I have just put the orientation like 20-degree tilt angle, true south azimuth angle, and then user needed. So when you are doing the simulation for your like standalone system, you need this consumption. You need this Excel sheet from the client side. How many number of that equipments installed in your appliances installed in your house? What are their powers, and in which hours they are using, and how many hours they are using, and in which hours they are consuming that power. So I just selected, like we have this file like uh, LED lamps. We have three lamps. Okay, their power like we have 10-watt lamp power. Daily uses like we say that it should be 5 hours per day. Okay, then we have one TV available, and one PC or mobile. Wattage like it should be like 100 watt. We just giving you that, and usage like 2 hours, because we have the PC and mobiles, and they are like that one. Now, if we have fridge one, like fridge, we have 1 kilowatt hours per day. Daily usage, and their watt hours like we have 24. Watt hours. Like we put 6 kilowatt hours per day. Okay. Then we have like this type of the appliances we are using. Like domestic use fans, like we have 4 fans available. Their wattage like 150 watt and hours like 6 hours per day. Okay. So these are the appliances I have put in that value. Now you have to, because you are saying that specify the hours, because I have put the daily hours 5 hours, 2 hours and 6 hours. Okay. Now you have to divide that one. So this fridge, they have already mentioned that it is full 24 hours they will be used. Now, LED at what time will be used? Like we have put the 5 hours. So we are using like from like 9 hours, 15, 16, like we are using from that 17, like this one, then this one, and this one. Like from 7 to 11, we use that LEDs, lamps flow, वगैरह. Then the TV, we have put that value like 2 hours. We mostly use in between 7 to 9, 7 to 9. Okay. Now we have fans are. We have put 6 hours per day, 6 hours per day. We just use that hours like in daytimes, like we use that one from the 10 to 15, and then mostly we use I think we have to put that hours should be 8 per day, and just the hours. And like we have this one, and then we use that in night time like 11 hours. Okay, how this will be used. So I've just selected this profiles. Okay, now it's okay. Okay, now you have to define the systems. You have to define the system. First of all, you have to define the storage. Like we have to select uh, that all manufacturers. Lithium ion, like we have lead acid batteries. Okay, on voltage basis, you have to select that one. Like we have this 100 ampere hours. Like we have 100 amperes hour batteries. Okay, 12 volt, 100 ampere hour batteries. Like we have selected the in four battery in series and in the parallel 11. Uh, so peak voltage becomes 48, global capacity becomes 11 hours, TOD at 80%, 42.2 kilowatt hours, the total weight, this kg, they have the cycles. Okay, now you have to select the PV array. You have to select the PV array. Storage, basically, when we select that one, they will basically take from the user value, which we have set. Now we have to select that one. Like we have selected that JA solar. We have selected that one, 550 volt. Okay. Now you have to select that controller, all manufacturers. Like we have that one, MPPT controller, 60 volt, 3.5, like 6.2 voltage. voltage is the controller out voltage does not match the battery package. Like we have to select that one 48 volt. This is one oversized. So we have to select that one. Like we have to select 8 PV modules. And the number of strings like we have selected like 10. No. Um, uh, number one. Okay, 11.4. Okay, so we have to select the controller power this one, and then this is like okay between 1 to 1 oversized. So we have to select that one like 5 watt. Now should provide the controller that is battery. Okay, at least per string per input. See, okay, number of controllers. Okay, now you have to put that for single four strings oversized. What is the main issue? Why they are creating that issue? Like we have 4 into 4, 4P module series and 16. Like 4 into 4 multiply with the 550 watt, 8.8. And we have this power, controller power 33 kilowatt. Okay. So I think we should use that one, like we have used that one. And we have to like we have to put that 11 kilowatt 11 kilowatt. So 11 means that 11 12 kilowatt systems, 12,000 divided by 550 50. So we need 22 PV modules, 22 PV modules. So we can that one, and the three number of strings we should select that one. Okay, now we have 24 PV modules, 13 kilonorm the PV, and then we have to decide the backup hours. The PV array is strongly oversized with respect to the user needs. This will reduce high unused energy. Backup. Okay. So, okay, no issue. So our system has been defined. We have just selected the storage. Okay. And then we have selected like if we use 12, 13, 14, 15, like we can use like we have this storage systems. We have storage like 57.6 kilowatt hours storage, our system. And our usage is that one, like we have usage that we need 335 kilowatt hour per month. Okay. Daily usage you have only you have 11.174 watt hour kilowatt hour. So you need 11 kilowatt hour is the your need for the first per day. And so you have to define like uh, system like less than, because they are mentioning that your storage is too much on the higher side, so unused energy. So we just decrease that one, like we just 8 these PV modules, so it becomes your battery is largely undersized with respect to the PV array. So we will decrease that one also. Like you can see that they have 30 kilowatt hour storage capacity. So it is now 4. We will in the parallel. So now it 15 kilowatt hour. So it is your recommended. R is less than 1.3 with standard the battery capacity equal to. Now you will decrease that also. Now you can decrease that one. So you can just select that one. Like you have 200 R R battery systems. Okay. And you just select that one. Like so you have 4 PV module. 4 means 4 into 550 means that you have 2.2 kilowatt hour the systems. And your storage now it's okay because your storage is 15 kilowatt hours and your PV array is 2.2 kilowatt hours and your inverter is 2 kilowatt hours or sorry 2 kilowatt. So now it's okay because they have planned power, they have mentioned that 2.3 resizing on the basis of their backup and their usage. So we have decided that. So now it's okay. Now you have to put the losses like free installation there. Ohmic losses like we have uh, 0.5% because it is a small cables like then the modules it is the gain like 0.4 and then you have LID 0.6% and this MPPT like this is the same one for that loss because they are too much lower side. Soiling like we have 2%. I mean the same one and then you have put that one. Now you can simulate that one. Now you have see that like we just sorry added covers. So I have just practiced that one, like mentioned that one, the Iran area, and that is the coordinate systems of that Iran area. And then you have this tilt angle, 4 PV modules, then lead acid battery 16 units, 48 watt, 400 amperes hours battery capacity. Then you have useful energy from the solar kilowatt hour per year, missing energy 13.6 kilowatt hour per year, and excess unused energy. This is specific production and solar. This is, and you have this crest, define the battery and other things. Then array losses and other things. You have detailed losses that. Then you have the user defined profile of that one. And you have this energy chart, E load, and then you have the energy user. This is the ratio like that one. So it is the report for the standalone systems. Because most of the time when you are using on the large scale project, you don't need that one. But maybe if you need that one, you can use that one. That is why I have just explained to all of you. If you need that one, if you don't have that specific PV module controller and other things, you can import that files from the check them from the vendor and they will provide for the PV module PAN file, for the controller or inverter you have OND file, for the battery you have BAT file like that one. You can check from the your client, sorry, manufacturer of that or vendor. So now we move on to our another simulation, which we are doing for the 3D shading analysis. I'm just clicking that one, new project. Yes, I'm just 14 class on grid system. Now, the location which I have just used before, that is why I am using that location again. Just selected this one and I've just saved that one. Project setting, I'm just using the same one like albedo 0.2. Oh, sorry. And this like -3. Now I'm just picking that variant name, class 14 class practice uh, on grid three-D shading analysis, and then 16.01 to 26. Now I have just import that file, PVC file. Okay. Just click on that. Here is the options, construction. Just click on that. Here is go to the file locations, import options. Import options. You can see that we have 3D scenes, 3ds file, DAE file, and PVC file. DAE we get from the uh, SketchUp. 3ds we get from the SketchUp, and PVC file we get from the PV case. Now I'm just clicking on that one. You also have that option, Helio 3D files, import ground data CSV, or import a ground image. You can use that one. I just clicking on that one and go into the my locations. That one, this one, and click on that one. Click on that one. Okay, best azimuth. I have this location. I have this location. That is why I am just using that one. No worries, fine. Okay. Uh, okay, okay, okay. Sorry. No. Cancer. Are you close? Okay. So I'm just going, basically, I'm mm, mm, making that in the standalone, but I have to make in the grid connected. So I'm just clicking on that one, 14 plus practice on grid. Then I have selected that location, this one, save that one. Albedo same like that one, and this will become 0.3. Oh, sorry, 3. Save that one. Then I have import. Sorry, I have just variant names like 14 class class practice On grid 16.1.2026. Near shading, I just click on that. File location, import options, and PVC import options. Okay. 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 Now go to this file. Select that one, like JA Solar. I have just selected that one. Then I have selected the Huawei inverters. I have that data. We have to do that one. JA Solar, then in PV modules like this one, 42,000. PV modules per strings like 28. This is the inverter, like 98, 99 inverters, pitch 10 meter. And then we have this one, the sheds like this time. The height above ground like 0.5 meters. So this is the data. I have just selected the Huawei inverters. From that Huawei, we have selected these options like H2, Sun 330 KTL, H2 is the option. And then we have this, this option. We have selected 99 inverters options. Then we have this 28 PV module per strings and PV 42,000 PV modules there. Divided by 28 means that 1500 strings. 1500 strings. Okay. Now you can see that this is the bifaciality option available. If your system is bifacial, you can use that bifacial PV module systems. Go in that simulation, unlimited sheds, like 30-degree is available. Pitch is 10 meter. They automatically pick that one because we have import the 3D files. They will pick that the pitch one, the shed height. So we have to just change that one, height above ground. Our system has a height above ground like 0.5 meter, which I have shown to you. This is height above ground 0.5 meter. And albedo 0.2. We have to change that also. Okay. And then we have to take that losses like structure shading factors. Basically, when your structure has some shading due to the purlin or the cabling and other things which have your structure has shading on the back of the PV module. So that will creating hindrance to the uh, sun rays. That is why we have to mention that percentage. So we just mentioned 5%. Like as an experience, we don't have proper, like you can just assume that the width of the purlin, their length, the area which you will calculate that one, and the total area of the PV module, you just click based on that one, you can imagine that. And these are the default values. Okay. Now click OK. Plan that one. Table that one. Now you have to put the detail losses. Detail losses. This is free mounted system because it is a ground mounted system. So it is free mounted. Now you have losses. Like we have, in that case, we have DC loss is 1%. DC loss is 1%. AC loss, we have aluminum cable for the whole systems, like 200 volt, but we have loss of 1.5%. Okay. And then you have 9 MV stations there. 9 MV station there for the 33 kV system. 9 MV stations. and their power is 6.050. Sorry, 6.50 kVA. Okay, and the length is almost like 1800 meters. Like we have 95 one. Okay, 70, 50, like 70. This is like this type of the voltage drop. And we have to just, I have just explained that you have to get that values from the client, the iron, no losses and copper losses. But for this transformer, we have these losses from the owner, no, sorry, vendor of that transformer. And they have given me the losses of 0.1% for the iron and 1% for the copper. So this value 0.1% means you have to get that one 0.1%. So means that 6.05 is the kVA. And this is 60.5 is the iron 1%. So it is one become one losses. Then we have 33 to 66 kV HV transformer. 66 kV HV transformer. Length is almost 100 meter, like general basic. Okay, now you have that power like 30 MVA, and these losses is 0.8, 0.8%. 30 means 0.08 divided by 100. So 0.024. You will get these value from the vendors of that transformer. I'm just putting on basis of my experience, which we have get that value from our vendors. So you don't have to confuse in that values. You just contact to the uh, uh, like vendor of that transformer. They will give you that values. Okay. So now we have to move to the module quality. I have just explained that one, and that LID 0.6. This you can put that one like 0.8%, and this 0.2%. But you have to calculate, like I have explained in the yesterday class, through that detailed study, detailed computations. You can calculate that values. If you need any help, you can refer contact in the group. I will just send you one Excel sheet for the previous experience, our previous experience. But when you are doing that things, you have to get the flash test reports of your any previous projects. Then on that basis, you will calculate these values. These values are too much on the lower side. I'm just on the safer side. We have put that values. So soiling, I am putting 2% because this area is too much like sandy area, not dusty area. This is the same one. Here I just giving the auxiliary power of like 100 kilowatt, and that inverter power is 4. These value we get from the uh, vendor of the inverters. Their internal consumption of the inverters. This is simulation for the aging tools, and then we have availability of 1.5%. Randomly in the daytime, like PM, Pakistan, 4 p.m. Okay. Now press OK. Then we are adding the BESS system in your systems. This BESS is not like the standalone systems. This BESS is basically the BESS which is connected to the grid through the PCS. It is basically the separate one. Like when we are working on the large scale project, most of the client will ask us to give the BESS. This BESS is basically used to for the three purpose. One is the peak shaving, one is the self consumption, and third one is the grid stabilization. When most of the time our grids are not stabilized, and we have to put that BESS to stabilize that one. And also the self consumption, if you have any self consumption like on the grid, you can use that one. That's best. And the third one is the peak shaving. You will cut off some energy from the solar and save in the energy in the battery systems and use at the time of the peak hours. Peak hours. So these are three systems. So I'm just adding storage system for your knowledge. I'm just putting that one as a self consumption. Okay. Just use that one as a like Huawei. We have like if we have any battery systems like we have no Huawei available. Like Samsung, Tesla. Okay. Like we have Tesla batteries available, and we have selected this ampere hour 260, 8 ampere hour 50-volt batteries. Like we have series like uh, four in series, sorry, two in series, and parallel we have like series we have like 4 1 6 and 8 on in the series one, like this type of this. Okay. Now you have self consumption like that one. If we have like self consumption maximum charging that one and discharge, like they have the DOD option of 95-degree. Okay. Self consumption, you can use that one. Fixed constant consumption, monthly value, daily. So we have just fixed value like kilowatt hours. We have fixed consumption of like uh, 50 kilowatt. We just put that value. Okay. And then press OK. Near shade is already available. Module layout, we don't need that one. Then energy management system. Like if we have grid limitations, like we have grid limitations, I will apply the grid limitation of like 25 megawatt. At the inverter level, limit at the injection point. So we are using as an injection point. Power factor should be like it should be 0.95. Most of the client will require that it should be 0.95. And then this is value PMV files method. So I'm just simulating that options. Now you can see that this is the report options. You can edit the cover. You can see that we have these locations, we have these PV modules, battery system available. You have inverter available there. Then you have 50 kilowatt or that fixed consumption there. And then you have the pitch area. Then you have that collector 715 sheds available. They have automatically take from your 3D shading factors. They have this like sheds the bifaciality available. You can see that albedo, this one bifaciality factor 80%, 5% rear shading and other things. This is the p-norm ratio available there, and you have defined that other things, battery setup and other things. Loss is available there. You can see that the shading analysis is available there. And this is the SLD available. If you want to add the 30-year graph, you can do like that. You can do. Go into the advanced simulations, aging tools. For the 30-year, we want that one, just from simulations. So we have now report options. So you can see that we have added 30-year graph available. Now you have to edit that one, aging tools. You can aging tools that one. I just selected that one. Now you can see that we have this 30-year graph, 30-year graph, an Excel sheet. So that is for the today. If you have any questions, you can ask. Yes, I want to save that one. And then you can just close that one. And just that one. Just we will see any other point in the tomorrow class, inshallah. Okay, guys. I think you have no any questions. We will meet again, inshallah, by in the tomorrow class.